In this video, we'll write the electron configuration for Mo and Mo3+. So I've written the configuration here for this molybdenum, but this isn't correct because molybdenum is a special case. It's an exception. So let's figure out how I got here, deal with the exception, and then we'll do the electron configuration for the ion. The periodic table here, I have it broken up into these orbital blocks, which is real nice. This is a very good way to figure out the electron configurations. You can also use the chart here, but I think this is probably more conceptually sound. So we find molybdenum, atomic number 42, so it has 42 protons. These are all neutral, so the protons will equal the electrons. 42 electrons. And here's how I've distributed them. I have 1s1, 1s2. Now that's full, so there's my 1s2. I go to 2s1, 2s2. Remember, s can hold up to 2. That's full. 2p1, 2, 3, 4, 5, 6. That's full, so I have 2p6, and so on. Eventually, I get down to the 4s1 and 2, which is full. Then I go to the 3d. D holds up to 10, so I have my 3d10 here. 4p6, 5s2, and then I go to 4d, and I need to have 42. So at this point, I have 38, I go 39, 40, 41, and 42. So this is the electron configuration we come up with using this chart. And if I knew my orbital blocks, I could just go down and I'd know molybdenum's here. It's going to be 4d1, 2, 3, 4. So I could have known what it would end it in right away, which helps you get the right answer. So here's the configuration that we get using the chart. Often with these transition metals here, these D blocks, you'll see the D before the S, and sometimes even before the P. So let's do that. Let's put the D's before the S. And that's nice because when we have these ions forming, these S electrons out here, we're going to lose those first. So this is a better way to write it, but it's still not correct for this molybdenum. Let's take a look at how we can fix that. So if we look at how the electrons are arranged within these orbitals here, we'll see that we have this 4d, which has 4 of them. They spread out, and then the 5s2, that's full with 2. But there's a rule that we need to consider here. That's that half-filled or completely filled d orbitals. So if this either had one more here, or it was completely full with 2 in each block, that would be much more stable. So what we could do, we can just take this one electron right here and move it over. So now when we've done that, this is half full. This d orbital is half full. That's much more stable. So that's going to change our electron configuration up here. So now in the D we have 5, and then in the S we have 1 less. So we have the same total. We have 42, but they're arranged differently. And this is the electron configuration for Mo. If you wanted to do Mo3+, you do this. Since this is 3+, that means we've lost 3 electrons. So we're just going to take 3 electrons away. So we'll take 1 here, and often you'll see 0 written, and then we'll take 2 from here. So 5 minus 2, that gives us 3. So this is the electron configuration for Mo3+. Sometimes you'll see people not write the 5s0. Either way. If you were doing molybdenum 4+, you would just take another electron here. This is Dr. B with the electron configuration for Mo and Mo3+. Thanks for watching.